But now we can since in this diagram, since this body is pulling this one downwards, we can there is an assumption that this force is acting upwards to pull the string back to its original form. So like that.
Yes.
Is that okay?
Yes.
So we are going to do resolving. So we consider each of those masses separately. So we consider m kilogram mass, then we get the net force acting on it using F equaling to ma. Maybe let us go to a whiteboard and then we can. So this is capital M, this is small m. So if we consider m, so we are going to get the resultant force, okay?
Yes.
So our acceleration here is going upwards, and here is moving downwards. So when we consider the m, here we shall say t is going to be greater than m2g, since the system is moving upwards. Okay. So we shall say the resultant force is t minus m1g. And then when we apply F equaling to ma, where F is the resultant force, so we shall say T minus m1g is equal to ma. And then we call this equation 1. Then we still consider capital M kilogram mass. So what will be the resultant force? The M on this.
mg.
Yes. M2g.
M2g minus
T.
Since
yes. So when we
downwards.
Okay. So here T minus M2g minus T is equal to capital M times the acceleration. So this gives us equation 2. So our aim was to get the acceleration. Okay.
Yes.
So we are going to solve our equations 1 and what? And 2. So what are we going to do?
Kilograms. We are going to solve simultaneously. Yes.
Alvin, say something. What are we going to do?
You're going to solve simultaneously, yes.
Simultaneous.
You can find them. Yeah.
How?
Here, we see that we are going to solve simultaneously and we eliminate the tension.
Okay, since the upper one is plus and the lower one is minus. So we can add equation 1
plus
and 2. Okay. So that we shall have T minus T. Okay. Then minus M1G, since it is a minus here, then plus M2G is equal to MA, and then plus capital M and A. So this will cancel out. So we can write this as M2G minus M1G is equal to MA plus capital. Then here we get a common factor, which is G into M2 is equal to common factor A, then small
m plus
capital. Then here what are we going to do?
We are going to make acceleration the subject of the formula.
By dividing by this.
By M, capital M plus M, no, divide by capital M plus M.
Capital M plus small m. So we shall have our acceleration equaling to M2 minus M1 times G. Then we divide this by small m plus capital M. So this will be our acceleration.
Yes.
Okay. So supposing they had asked us for the tension, I would get one of these equations and substitute the value of what?
Of the acceleration.
Of the acceleration, and then we get the tension in the string. Okay.
Yes.
Okay, so which is something like this here. Okay, much as here they maintained M1 and M2, but it is almost close to the same answer. Okay.
Yes.
So later, this video also talks about the connected particles. And then they went ahead to substitute and calculate the value of the tension, like what I'm telling you. Okay.
Yes.
This one as well talks about two particles which are still connected. So we have A, which has some forces acting on it, and as well B, which still has forces acting on it. So they still we consider when we consider, let me see, two particles. So since the surface is rough, there is some friction, I think, which is 0.80 G. Okay.
Yes.
There's friction here. So when we are considering this movement here, so we shall also resolve here to get the resultant force. Okay.
Yes.
So the motion is this way, so we shall have T 0.G. Okay. To get that. Then we also, this one we get 0.88 G and equate it to A. And then get use of acceleration which is given 0 squared g. Okay, so it is all about to find the
Joel, what's up?
Man, nothing much.
Let's
For
go
me, I
live
wasn't
from.
here with the teacher.
Let's go. Let's go live from. Let's go.
Yes. Let me come back.
Saying what? Were you saying something? I did not hear you.
internet had disconnected me.
Oh my God.
Okay, the internet is somehow unstable, but we shall maneuver.
Yes.
Okay, so we had
Stopped on the
read
other
our
day.
question. Okay. So assuming this is the 3 kg. Then we draw the 1 of 5.
Teacher. Teacher.
Okay, so same string, this one tension.
There's today teacher's network. Shall we move on?
Then we have the way 3. Yeah. Contrast, please.
Teacher, for me, I'm not getting you.
Yes, you are asking something.
Teacher, we are still on the other question. We are still interpreting it. The
Yes.
previous.
So this was 3G. 3 kilograms. This is 5. So this one has a weight of 5G. Then this one will have 3G. Okay. Then the tension, because it is the same string, so it has the same tension. And because 5 kilograms is greater than 3 kilograms, the 5 kilograms is going to pull the 3.
Yes.
So our acceleration will move this in this direction. Okay.
Yes.
Yes. So this is a diagram showing all the forces that are going to act. This system here. So this one is maybe
the surface.
Fixed to that. Okay. Then after indicating all our forces, we begin resolving. Okay. So when we begin with the 3 kilogram mass.
3 kilogram mass.
What will the resultant force be equal to?
Resultant force will be, since the body is moving upwards,
yes,
at 3 kilograms,
yes,
we shall have our tension minus M1G.
3G.
So, M1.
The mass has now been substituted with the quantity, okay? So it is 3 kilograms, so we have 3G, okay?
Yes.
And then when we substitute in F equal into MA,
by T
minus 3G
is equal to 3A.
3A. This becomes equation what? 1.
Equation 1.
And then we also consider the 5 kilogram mass. What will be the resultant force?
Which is our 5 RF will be our 5G minus T, whereby our F is equal to our MA. So that our force will be 5g minus t is equal to 5a. Equation 2.
Okay.
Yes.
So we are now going to add, since this t is positive and this t here is what? Is negative. Yes.
Add equation 1 and 2.
So we shall have t minus t is equal to minus 3g plus 5g is equal to 3a plus 5a. So this cancels 5 minus 3.
2g. We
So
shall
2g
have 2g, which is
is equal to
8a. Yes. 8a. Whereby our a will be 2 over 8.
2 over 8. And the 2 over 8 can be written as
1 over 4.
1 over 4.
Meters per
G.
second. G.
Meters per second squared. Okay? It is okay to leave the G there. And if you are not comfortable with the G, you can substitute for its value. Okay?
Yes.
Which is always given on the question paper or in the textbook or anywhere where you find the question. Okay?
Okay.
Then now to find t, we shall choose one equation and then we substitute there the value of g. So which equation can we use?
We use equation 1.
Equation 1.
Yes.
T minus 3g
T minus
equal to 3a.
Equal to 3a.
So t, so we can take the g there, then 3 times the acceleration, which is g over 4, then
Yes.
plus 3g.
Plus 3g.
So this will be 3g over 4
3g over 4
plus 3g.
Plus 3g. LCM.
If you have a calculator, you would just add direct. Okay, LCM would be 4. Let's take it here.
3 over 4
So 3g. So 4, this would be 12g.
12g over 4.
Over 4.
Which
So we
is
should give us 15.
Over 4.
G.
15 over
So our
4.
T will be 15 over 4.
G. Newton.
G. Newtons. Okay. Alvin, are we okay?
Yeah.
Okay.
Teacher.
Yes.
I have a question.
Yes,
How
please.
come the acceleration due to gravity of physics is 9.81 and this one is 9.8?
Yes.
What is the difference?
There is no difference. The only difference is that they are just made to look different. But 9.8 and 9.81, they are almost close. But in some mathematics books, they use 9.81, and then in others, they use 9.8.
So no big difference.
Yes. The difference is just minimal, but they choose what to use. Remember, even in O level, you were using the what? 10, isn't it?
10.
Yes.
10
But
meters.
But the exact one should be around 9.81 something. But okay, we just make approximations because we want to use the to simplify our calculations. Okay.
Oh. Okay.
Yes. So we have finished this one and that one. So this one is also a video on two particles connected by a string. Okay. Which you should come and watch later.
Okay.
Okay, these ones are also showing connected particles. There was some image here which disappeared, I think. This video also shows two connected particles.
Oh.
Okay, then we have here this example, which says a car of mass 600 kilogram towards a trailer of mass 250 kilograms in a straight line using a rigid tower bar. The resistive force of the car is 200 newtons. Then the resistive force of the trailer is 80 newtons. If the forward thrust, in other words, if the forward force produced by the engine of the car is 800, what is the acceleration, the tension in the tower bar? So here, since it is a straight line, so this is the resistance, this is also resistance, which is so these ones are opposing the motion. Okay. The motion of the car. So we are going to still use F equaling to MA. So our resultant force will be this force of the engine. Okay.
Yes.
Force of the engine minus the two opposing forces. So that will give the resultant force. Okay. Then so let us write go back here. So the resultant force will be 800 minus 200 minus 80. So this gives us around, this is 600, 520. Okay.
Yes.
And then when we use F equaling to MA, so 520 is equal to the mass. So they had different masses, so we add them and multiply the by acceleration. Okay.
Yeah.
Such that later would do what? Divide and get the value of A.
Okay.
Yes.
Which is 520.
First, you still remember the figures in your head?
At least.
600 plus 250. Yes. So that would give us our acceleration as 0.612. Okay.
Yes. Our 520 divided by 600 divided by 800. 0.6.
So also wanted the tension of the tower bar. Okay.
Yes.
So here we are also saying using F equaling to MF for the trailer only, because the tower bar is in the trailer, is in the side of the trailer. Okay. Because had the car of mass this, tower as a trailer of mass this in a straight line using a rigged tower bar. So so we get the one of T minus the resisting force, the resistive force of the trailer, and then we equate that to MA, and we'll get our tension as 233 what? Newtons.
Tons.
Okay.
250 times 0.65 plus 80. Okay. 250 times 0.65 plus 80. Ah.
Are you done proving?
Okay. Teacher, for me, I was getting 243 because because on my acceleration I was getting 0.65.
Did you round off?
Let me see. For me, I was getting 0.65. I did 500 as the first, then divide by 800. Then I was getting 0.65.
No, there's something you left out. Because the forces, we have to get 800 minus 200 minus 80. And then we equate it to 600 plus 250 times acceleration. Yes.
Okay. Yes. 250, yes. I was making a mistake.
Okay, so let's for the minutes, let me explain about connected particles on an incline, and then I'll send you some work to do later.
Okay.
So if this is the horizontal, okay, maybe this is the incline, and we can make it like this. So a particle is inclined at an angle theta and is connected to another particle still by what? By a string. Okay? Yes. So this particle will have its weight here, which would be mg. Then this mg has this component that is perpendicular and this component that is parallel, and as well it has the normal reaction R.
Inextensive.
So if this is capital M, this would be capital M times G. Okay.
Yes.
So if we go back to some trigonometry, this angle will also be equal to theta. Okay.
Yes.
And if we draw a dotted line here, okay, assuming this is dotted, and we extend this one here, so this would be 90 degrees. Okay. So this side here would become a side which is opposite to the angle.
Yes.
And opposite is sine, so this would be mg, sine of what? Of theta. And then this is adjacent, it would be mg, cos of what? Of theta. Okay?
Yes.
So this force here would be mg cos theta, and this one would be mg what? Sine. So this one is the same as mg sine theta. But these ones are represented using a dotted line. These two forces here. Okay?
Yes.
Yes. So still when we come to resolving, if the acceleration is moving this way, we still do the same thing. We are going to get t here minus the mg what? Minus the mg sine. And we equate this to ma to become equation what? 1. Then when we come to this point here, we shall have capital mg minus t is equal to capital M and what? A. And this would become my equation.
Equation
2. So we'll still add the two equations and find the value of the acceleration. And then after substitute and find the corresponding value of the what? Of the tension in the string.
Okay.
Okay?
Yes.
Yes. So when we meet again for this paper, we shall look at when we have more than one pulley. So a system where we have more than what? One pulley. Maybe one is fixed. Let's give an over some example. So can have one fixed here, then one movable, and another one fixed, so that our particles are connected in this form. So this one can as well happen. Then we can have another one where one is connected to another. So maybe this is one. Then this one here is still connected to more two. So you can as well search and read more about them. Okay? Yes, so this is what we are going to look at, but you can as well do some more research on them. Okay?
Okay.
Yes, so otherwise we shall meet again. So I'm going to type some few questions like 3 and I send them to you. So do them and then you send me back the answers. I hope you know how to type the math in Microsoft Word or PowerPoint.
Teacher, how do you type it?
Sure. You don't know how to type it?
I know how to scan.
Yeah, okay, it is okay. You write very well and then do the scanning.
Okay.
I think Alvin is also good at scanning.
Teacher, I will scan and I send it into your inbox.
No, on the side.
On the side.
Under messages. Yes.
Okay, I will try.
Okay. Bye for today.
Okay, thank you.